Hello. Okay, we meet again, but unfortunately, we're not meeting face to face today. So this is going to be a pre-recorded lecture for the topic on technology with respect to economic growth. Okay, first of all, my apologies for the problem ataupun misunderstanding that we had um, last week. Basically, it was my mistake, I suppose, because I overlooked the um, what do you call the message from Dr. Wong regarding the changes in the schedule of my lecture. So just to make up for that, I'm recording a lecture, um, assuming that we will not be meeting face to face. So here it is. Yeah. I hope you enjoy the video and watch what I have to share with you in this particular session. And it will probably be split into two parts. The first part will be basically looking at the what I call the solo model of growth and where technology um, play its role in terms of economic growth according to that model. So, and then the second part will be just some further explanation of that and the contribution of what I call technology in terms of economic growth in a particular country or countries. Yeah. Okay, so let me share with you my slide. Okay, so all right, so technology, one of the ingredients for economic growth. Okay, all right, there we go. Okay, so technology in the context of the solo ataupun solo swan growth model, economic growth model, it has been assumed, and also there's some empirical evidence to support that as well, that technology can drive long-run economic growth. Okay, in other words, if capital and also labor, normally for capital labor, the marginal productivity becomes smaller and smaller, right? And so that will gradually lead to more or less it won't stop, but slower economic growth. But according to some of the experts, economists, and all that, technology can help to solve that problem, right? So the technological knowledge basically covers almost everything, which refers to a way of getting more output from the same input. Yeah. In other words, you can increase productivity from the same amount of input that you have. In other words, capital and also labor. Yeah. Now we can include technology or technological knowledge in our model. For example, here by letting A to stand for ideas, yeah, ataupun technology that will help to increase productivity. So we will have a production function as such, yeah, y equals to a and what I call the square root of k and all that. Yeah? So, or as a function of knowledge and capital. Yeah. Okay. So in the Solow growth model, by the way, Robert Solow was a Nobel Prize winner, a Nobel Prize laureate. According to his model, the total output, which is Y, or total revenue output production, in other words, of an economy depends on number one is the physical capital. Of course, that one has been emphasized, has been explained before this. It is one of the most important elements ataupun input, yeah, for economic growth. And besides that is the human capital. And I think, as I said, as I mentioned last week, I think Dr. Zul has also mentioned quite extensively on the issue of labor, and also maybe human capital, I don't know. But so we can say here EL to stand for not just labor, but also the education factor related to labor there. Yeah? And the other one is ideas ataupun technology lah, which is using the symbol A there. Okay, so this then can be expressed as the flowing production function. In other words, Y equals a function of A, function of knowledge, function of capital, and functions of human capital, ataupun the labor as well. All right. So I think you probably have gone through this before. Yeah. So I don't think I need to explain further on that. Yeah. Okay. So in this neoclassical growth model of Solow and Swan, the models basically deals with the growth of GDP per worker, the growth of production lah. In other words, production or productivity per worker via capital accumulation. Yeah? Capital accumulation. And the key elements in this model is one is the production function, yeah, as we've seen in the previous slide, where the GDP depends on technology, labor, and physical capital. Okay, and the other key element is the capital accumulation equation, where we can see that change in net capital stock will be equals to the gross investment. In other words, this will be the savings minus the depreciation, ataupun saving less depreciation. Yeah. So the questions actually are some question that crop up, or what we have in mind. One is how does capital accumulation net investment affect growth? And we have seen that last week actually about the role of capital in the production function, and also question of the role of savings, role of depreciation, and population growth as well. Yeah. So population growth will have an impact or have the roles in terms of economic growth, okay, and also the role of savings and so on. Yeah. But what I'm dealing here with you today, or in this particular lecture, is looking at the role of technology. Yeah, the role of technology in growth model. Yeah? In other words, in economic growth. Okay. So Solow growth model is indeed a long-term model of economic growth that looks at three main factors. Yeah, three main factors, which is capital accumulation, labor growth, and also multi-factor productivity. Yeah. So the Solow growth model is considered an exogenous model of economic growth that look at changes, so analyzes changes in the level of output or change in the level of output in an economy over a period of time as a result of the changes in the population growth, that will affect labor, by the way. The savings rate, changes in the savings rate, and also the rate of technological progress. In other words, it also includes how much investment is made in technology, yeah, um, in the process, yeah, okay, of economic growth. So the model is indeed exogenous, and that attacks the investment rate, the depreciation rate, and also the growth rates of the workforce, human capital, and also technology as well. Okay, so all of those are considered in the model ataupun the equation actually. Yeah. Okay, so the indigenous variables here are the output and the physical capital stock, and the rest are the exogenous variables, by the way. Okay, so technology is considered as one of the factors considered as exogenous, yeah, outside, in other words, something that's outside of the system. Yeah. So, and by the way, Robert Solow and Trevor Swan, those are the two persons. They first introduced the neoclassical growth theory in 1956. We state that the economic growth is the result of three factors, as we've seen earlier on, yeah? Labor, capital, and technology. So while an economy has limited resources in terms of capital and labor, the contribution from technology, according to their theory, um, to growth is boundless, in other words, limitless, yeah, contribution. In other words, growth will continue, yeah, it doesn't stop, yeah, boundless. So the idea, yeah, the Solow growth model is more or less designed to show how growth in the capital stock, number one, growth in the labor force, yeah, and also advances in technology will interact in an economy, and how they affect nations' total output of goods and services. Okay, so that is the Solow growth model. Yeah. Okay, so that's I'm not so very keen on this equation and all that, because mathematically I'm not very good. But anyway, this is the equations, the Solow one equation. Yeah, the two things here. Number one is the production function equation, and the other one is the capital accumulation equation. Yeah, so in the production function, Solow and Swan analyze how these two equations of production function capital accumulation equation interact, and y, which is the output, yeah, output, and k, which is the capital. These are the indigenous variables, while as the others are exogenous variable. Yeah, for example, the serving the depreciation, yeah, and growth rate of labor, and also knowledge considered as exogenous variables ataupun parameters. Yeah. So the outcome depends very much on the exact functional form of production function and the parameter variables. In other words, it is influenced by the interaction between the parameters, yeah, and the production function. Okay, so the neoclassical production function assume that there is diminishing returns to capital or labor. That has been what earlier theories believe, in terms of economic theories believe, regarding the production functions. Yeah, so diminishing returns to capital or labor, which is often referred to as the diminishing returns. And also, the other assumption is that there is going to be a constant return to scale. Yeah, in other words, doubling of capital and doubling of labor will double production. For example, the Cobb-Douglas production functions, as you can see from here, I will not there to discuss is in every elements in here, but basically what you can infer from this function, production function, is that Y, which is the output, usually measured in GDP per worker, is a function of capital and labor ratio. So labor ratio here is the, in other words, the capital to labor ratio is the amount of capital per labor, actually. Yeah, so that's capital labor ratio. That's the one that influence the output. Yeah. Now, the other thing which you have to consider here is that this big A here, big capital A here, which is the knowledge ataupun technology. Okay, so in other words, technology will have to influence capital, will have also at the same time will have to influence the role of labor, in the production function as well. Okay, so you can see in this figure here, where on the y-axis the output per worker, and on the x-axis the capital per worker. So basically, if we assume that that knowledge and labor is constant, in other words, no technology growth, no labor growth, you will expect a curve to be concave in shape, concave slope, as it is reflected here. Okay, so there is going to be a diminishing return. As more capital added per worker, the incremental ataupun the marginal productivity becomes less and less. So you can see it's instead of going up, it's slowly flattening up there. Yeah, that indicates that there is a diminishing return. Yeah, so GDP per worker and capital. All right. Assuming there is no knowledge, no new knowledge, no innovation, and so on. Yeah. The equation, accumulation equation, on the other hand, is where you can see that if A and L are constant, then you can show that with this equation here, dk over dt equal to sy minus, this is, what do you call this, alpha k, which is the depreciation, by the way, depreciation, and this is the savings ratio and income. So this is a differential equation. In other words, the change in capital to labor ratio over time, dk over dt, will be equal to investment, saving per worker. Saving per worker, this SY is a saving per worker minus the dk ataupun bukan dk, alpha k, which represents the depreciation per worker. So any positive change in capital, will increase, or in K rather, will increase the Y, the output and generate economic growth. So any positive change in capital will increase the revenue or the income and generate economic growth. And growth will only stop if dk over dt equals to 0. In other words, there is nothing, no more increase in the production. Okay, so that's basic. This is the equation down here if you want to look at it in more details. All right, so graphically, we can look at this, the impact of that. For example, this is the capital per worker and this is the output. So the more, so the production function is where you have, if you add more capital per worker, you would expect increase in saving, but at the same time, some amount of depreciation as well. Depreciation up there. So this is the line of depreciation. And then the net investment is considered as in this area, below the curve there as well. Okay, so savings equals to the gross investment, right? Okay. Also, you can see from here, instead of having just a line like this, where SY and alpha K here, you could with the penggunaan teknologi, the use of technology or investment technology, you can increase the output per worker as we add more capital per worker in the industry or in the economy lah. Right, so you compare between this curve down here, this is the old one, and this is with the add of technology. Okay. All right, so that is the Solow-Swan equilibrium. Okay. Now, so the GDP per worker will converge to Y equals to A bracket K alpha. That's a formula. So in other words, if A is and L are constant, Y is also constant. So there is no long run growth. So you need to have technology will have to improve. We have to improve in order, even if labor is remain constant, technology will have to improve in order for growth to continue, to increase, in other words. Okay. So the question is, what happens if savings increase? Right. Normally, it would be if saving increase, some of those savings will also increase for the purpose of investment, right? So, so raising saving increases, it will increase capital and why, but long run growth will still be zero. Even if S1 move to SO and below and so on, So it still depends on the other important factor, as we have seen earlier on. So this kind of thing, the leveling effect ini, where long run growth equals to zero. So the growth increases initially, in the short run, growth increases because the economy moves to a new steady state, but there is no permanent growth effect. So this is, again, this is just to see between SO, S1, SO, savings one, savings zero. It is the impact of saving tadi lah, yeah, between SO saving one, saving or original saving Y, original saving one over here. So unless, see again, what this diagram is showing is that you can increase output with the injection of, or with the addition of technology, or with the addition of knowledge, yeah, in there. Okay, so you still can increase from capital 0 to capital Y. Can increase only if there is technology involved, yeah, but very little or very insignificant impact if technology stays zero or no improvement in technology, in other words. Okay. Okay, so that is with impact of saving. Yeah. What if labor force grows? What will be the impact of the effect on the equation? Yeah. Okay. So again, just to show you, sharing with you using this graph here. So as population growth grows, yeah, then that will reduce the equilibrium level of GDP per worker. Yeah, that will more or less reduce the equilibrium level. However, long run growth will still be zero if there is no technology involved. Yeah. Okay, so itu yang kesannya lah. I mean, you can, as we've seen early on, you add labor, you can increase production. Yeah, but as we have seen early on, based on earlier theories, the marginal production per worker will decrease. Yeah, because of that marginal return. Yeah. So yeah, so it's basically that's the impact of labor force. You can increase production up to a certain point, but the marginal increase of production or productivity will decline as you add more labor force into the economy, yeah, into the equation. Yeah. Okay, so we can illustrate this with a graph. Yeah, for example, in this graph here, right? Again, this is still the growth of capital per worker, right? And this is, the distance between lines is the growth of capital per worker. In other words, if you inject in or put more capital per worker, then the net effect is, as we have mentioned early on, it will increase production. Yeah. So if you look at from this graph, so the distance between lines is growth rate equals the growth rate of capital per worker. So you can see from here, this is the net investment, and over here it is the net disinvestment. In other words, the production, yeah, saving will be less on this side as you increase capital per worker, but at initial stage you have a lot, yeah, more savings, yeah. So saving equals to, or investment equals to savings times the average product capital, the average product of capital. Okay, sorry. Dia kata tidak ada orang dengan saya. Memang tidak ada orang, I'm alone dia. Okay, so so the distance between the lines represent growth in capital per worker. Yeah, right. So this side will be negative, this side will be positive. Yeah. So what are the important things with regard to Solo's models here? Yeah? The model states that investment in capital cannot drive long-run growth in GDP per worker. Okay, that's one. Yeah, capital. Investment capital alone cannot drive long-run growth in GDP per worker. Okay, so there is a need for technological change ataupun technological progress. In other words, growth in A, if you go back to the equation, the growth in A to avoid diminishing returns to capital. Right? So there is no, I mean, you add more capital without improvement in knowledge, in technology, the productivity will not increase as much as you would like it to be lah. In other words, kalau ikut apa yang dia kata tadi, zero growth, ya. But Easterly, for example, in 2001, he argued that capital fundamentalism view was widely held in World Bank. World Bank apa nama percaya sangatlah, ya, IMF juga. Okay. This is the view from them. So inject capital to increase economic growth. Yeah. So they believe that, IMF also believe that. From all the way to from the 1960s all the way to 1990s, despite lessons from the Solo model, right? So in terms of policy lesson here that we can you can look at is that for both World Bank and also IMF or whoever lah, yeah, don't advise poor countries to invest without to invest capital and all that without due regard for technology and incentives. That's the bottom line ataupun policy implication there. Okay, so kalau nak invest capital, make sure that it also comes with technological progress as well. Yeah? So what if technology grows? This is the next question. We have seen what if savings grows, what if labor growth grows and all that. We have seen that earlier on. Okay, so in this case, we consider y, the output equals to A, K, alpha, yeah? And Sy will be S, A, K, alpha lah, more or less, yeah? So that would imply that output can grow on increasing, okay? Not approaching zero growth. In other words, the growth in the economy will continue to grow to keep increasing lah, in other words, yeah. So, for example, we consider marginal product capital, MPK tadi. So if A increases, then MPK can keep increasing. Not unlike what happened to if you're looking at if there is no A involved there, yeah. A is taken out from the equation. So if A increases or knowledge or technology increases, then the marginal productivity of capital can keep increasing and no diminishing return to capital as we have seen in earlier models. Okay, so in other words, it implies a positive long-run growth. So that is the impact of technology. So if technology or A grows, it will have a positive long-run growth for the economy of the country. Okay, so we can see it from here. This is just a graphical representation of the production function shifting up, yeah, with every level of knowledge ataupun teknologi. So, okay, with technology level 1, level 2, level 3, and so on. Yeah, so they keep on increasing. Yeah, with additional capital to labor tadi lah. Okay, so that's more or less to illustrate that point. Now, I will not go through this, but this is for your reference. Those of you who likes to look at formula and so on, yeah. This is to represent what this is, yeah, on this side, right? Mathematically represented here. Okay. So the output capital per effective worker diagram can be illustrated like this. In other words, if you look at this diagram, if y over AL, right, this is the equation tadi, is constant, the growth of y must equal the growth of L. Right? In other words, growth in the output will be equals to the growth of ataupun directly related to the growth in labor plus the growth of technology tadi ya ataupun knowledge. So that will have impact on the GDP per worker. In other words, the growth in GDP per worker must equal the growth in the technology ataupun investment in technology. So the idea is just to prove that in an ideal situation, yeah, the impact of technology will have a positive effect yeah, on growth in the economy, yeah, ataupun in productivity, in production, sorry. So in a way, we can summarize the Solo-Swan model. So first of all, of course, it is a neoclassical growth model, which implies that countries will converge to steady state GDP per worker if there is no growth in technology. Yeah, no growth in technology. So, that's the first one. The second one is that if countries have the same steady states, yeah, poor countries will grow faster and converge. In other words, will catch up with the developed countries. Okay. And we call this more or less the classical convergence ataupun convergence to steady state in the model. Yeah? But changes in savings ratio causes what is called the level effect we've seen earlier on, but there will be no long run growth effect as a result of changes in savings ratio. The higher the level force growth, ceteris paribus ataupun what it means that everything else being equal, it implies that if higher level force growth, it implies that there will be lower GDP per worker, yeah, per worker, productivity per worker, in other words. Okay, so that is, in other words, if there is no without the impact of knowledge atau technology in the equation. So one question that I mean, this is just for you to think about, yeah. If you can explain, yeah, the effect of an increased investment in technology and on economic growth. What effect does it has, yeah? Or if you increase investment in technology, yeah, whether it is related to capital or is it related to labor and so on, yeah? What effect will it have on the economic growth? Okay, we have more or less we discussed a bit about that in the earlier discussion. So that's more or less ends the first part of the of this lecture today. So while before we go to the second part on part 2, I would like to take a break for a few minutes, yeah, and then I will continue again. That is, so let me pause, yeah. Okay. Yep. My apologies. I was supposed to record the didn't work. The recording stopped, so I will have to do the second part later on. Sorry about that. Um, the presentation was on, but unfortunately the recording was not done. So I will do the second part later. Thank you.